Hey, I'm Kristen Eykel. I'm here in beautiful downtown Calabasas with Dr. Gary Greenberg, who lives in Maui these days, but he travels all over the world speaking about his passion, and he's going to share a little bit of that passion with us today.
Hi, Kristen. Good to be here. I want to talk a little bit about my passion, about being able to see things that have not been seen before. When I was young, I started getting into microscopy and photography. And I did a lot of time-lapse photography, because in time-lapse you can see things in patterns that you're never able to see before. So slow motion, time-lapse, microscopes and telescopes have been my passion. I've been doing this for a long time.
So the lens that this man sees the world in allows you and I to be able to see things that he can then grasp. He also is the inventor of the 3D microscope, which is really quite cool because you're taking something that we expect to see in a flat dimension and suddenly having it have multiple dimensions.
Yeah.
Why do we like to see things in multiple dimensions? What does it do inside of ourselves when we see that way?
Well, I think seeing things that we've never seen before, seeing things for the first time, really enlivens our spirit to be on the earth. When we travel, everything is new. And seeing the world anew is really important for our soul. And so that's what microscopes and telescopes and time-lapse and slow motion allow us to do. As human beings, we're locked into a certain space and time. We see the world about a heartbeat at a time in terms of the time. So time-lapse allows us to see things that happen slowly and see the patterns that are there. Slow motion allows us to see things, we're fascinated by slow motion because we don't see things that way. In fact, what happens in the world around us happens really quickly. We see only a glimpse of what's happening. So let me give you an example of what I'm talking about. We see things about a second at a time. Time is broken down into little bits, little discrete bits, and those little discrete bits are called Planck time. And Planck time is about...
Not the same as plankton. Just to not confuse you with plankton. This is Planck time. Okay.
Planck time, a guy named Max Planck, Planck time is the smallest unit of time that there is. There's Planck time and Planck space. And that time, in 1 second, there are trillion bits of Planck time in 1 second. And things are happening on that level. That's how
all
fast.
The time.
That's how fast things are happening. So we only see we see things a trillion times compressed. We don't see it that way. That's why it's so amazing to see slow motion. We're so sort of enamored by it. The same with space. Space has chunks of time too. So space can really be seen in a really different way if you use microscopes and telescopes. So we only see things on a certain level. We can't see things smaller than about 1/10 of a millimeter.
And if you go below the atom?
And if you go below the atom, then things are even much more smaller again.
But when you go much smaller, isn't there then suddenly even more space?
When you go smaller, there's a lot of space.
How does that happen? Explain this, because that's really this dichotomy of amazingness that I think is so fascinating about this, and how we can see that and then understand it, because we think this is solid.
Yeah, so we can, for example, in a microscope today, we have microscopes that you can see atoms. You can see an atom. You can see where an atom is. So there's these scanning microscopes where you see a lattice work of all these atoms, but all that shows you is where the atom is. Most of that is empty, because the nucleus of the atom is tiny inside of that. And then these electrons are really kind of a cloud of energy around it. So most of the atom is empty. So when we see things really small or really big, we use telescopes to see things that are far away and big, like stars and nebula and things like galaxies.
Black holes out there.
Black holes and galaxies that are made of, a couple billion stars. So for me, being able to see things that we've never seen before really excites me. So every time, I work with 3D microscopes. I've invented a number of different kinds of 3D microscopes. Every time I look at them, it's different. Things are different and surprising and amazing looking. So I get a real big kick out of just looking at, I look at sand through the microscope. People will think, well, what a stupid thing to look at. But sand
His sand,
is amazing.
if you've never seen his sand through the microscope, you've got to check out his work. It looks like crystals and stars, and it looks like little microcosms of what you see in the large scale. So there's little itty-bitty shells and little itty-bitty representations of what you would see in like large mountainscapes, and these are all minuscule pieces of granular sand that is just so beautiful.
It's kind of mind-blowing because you think of there's about as many grains of sand on all the beaches of the world as all the stars in our universe. Every one of them is unique. Every single grain of sand is unique and different. More than, they say every snowflake is different, but they're, still based on a six-fold symmetry. But in sand grains,
this is really different.
They're really, really different. The colors, the shapes, the patterns. It's you would never guess that sand is more than just little green rocks, but it really is. And it kind of makes you realize how unique, if every grain of sand is that unique, imagine how unique each person is.
Well, that's what I think is really beautiful about that, is that you can then get into the person and see how even though we're all made of similar atoms and molecules and carbon and oxygen, we have all these little pieces that we're all the same of.
Yes.
Actually, they all operate slightly differently to give each of us our makeup.
It's put together. So for example, as you said, an electron is an electron. An electron here is the same as the electron a trillion miles away from here. And a hydrogen atom right here is the same as a hydrogen atom across the end of the universe. So when you put these things together into molecules and into people, and animals, and grains of sand, everyone is unique.
Why are they unique? What does it serve for them to be unique?
Well, that's the act of creativity. The act of creativity is bringing these little Lego bits together. We have these little bits and pieces of atoms and molecules, and when they get put together, you get something new each time.
So the question is, and I agree with you, we get these little Lego bits of information, as he's saying, and you put them together, and you make something new. So who's the observer?
Well, that's a good question. It depends who's observing what we're looking at. You can observe so many different points of view. So if you look at any bit of reality, you can look at it from a multiplicity of points of view, and they're each different. But to really understand what it is, you have to look at it from all points of view. So this is what science does. Science looks at things from a multiplicity of points of view, and then puts together a model of what it is to understand, what actually is happening, what actually is there.
But from that perspective, because
well,
then
from
you
multiple
then,
perspectives, right. From multiple perspectives. So you may look at something visually from different perspectives. You may use microscopes. You may do chemical analysis. You may start looking at the quantum reality of it. When you put all these different points of view together, you begin to understand what that thing is in reality. And that's what scientists try and do. They try and make models of reality by looking for multiple points of view.
So this is the whole view, if you will. This is like the holistic or the holograph
yes.
of everything altogether.
Yes.
Holograph of science and of art.
Yes.
Dr. Greenberg, thank you so much. It's a pleasure having you.